EDX Core Pure Sequences in Series 1 Summing Series, looking at the standard formula for the sum to n terms of R. So how do we find the sum of terms called R, starting at R equals 1 and finishing at n? So we're just going to look at a couple of features of this. So what does this summation look like? So when R is 1, we get 1. When R is 2, the term is 2. When R is 3, the term is 3. When R is 4, the term is called 4. When R equals n minus 1, the term is called n minus 1. And when R equals n, the term is called n. And of course sigma means the sum of. So we're looking at the sum. Don't forget there could be a number of terms in there, so we don't write them all down. We're looking at the sum of integers starting at R equals 1 and finishing at n. The other thing to notice about this, if we look at the sum of the first term, is obviously 1. If you look at the sum of the first two terms, we get 3, and the sum of the first three terms, we get 6, and the sum of the first four terms, we get 10. And you may recognise these answers, these summations, as triangular numbers. So we're going to be looking at those in a moment. So there's the sum of integers from R equals 1 to n, 1 plus 2 plus 3 plus 4 plus 5 plus ... plus n. One way of doing this, and don't worry if you haven't met this at the moment, is to realise that this is an arithmetic sequence. The first term is called 1, the common difference between each term is 1, and you can find the sum of this pattern using a formula that you will come across shortly in your maths course. And when you do use the formula, you get the sum of n terms is n plus 1 over 2. So don't worry if you haven't met that just yet. We're going to derive the answer in another way. So we've seen that the sum of the first n integers can be written as n times n plus 1 over 2. And we're going to demonstrate this formula looking at the sum of the first 5 integers. So we know this summation is 15. So if we represent that as a triangle, 1 add 2 add 3 add 4 add 5, we can see that the total is 15, which is a triangular number. If we now replicate that triangle and join it to that, so we've got two identical triangles there. The interesting thing here is that that is 5 and this side is 6. So at the moment, the total number of dots is 5 times 6. But of course, we only want the set of black dots, not the red one as well. So we need to divide that answer by 2. So to find the sum of the black dots, it is the sum of integers starting at R equals 1 and finishing at 5. And we can see that it is the total area of the rectangle, 5 times 6, over 2, which is of course 15. So there's a little demonstration that this formula, n times n plus 1 over 2, does work. So a well-known math problem is to find the sum of the first 100 integers. So we're looking at 1 plus 2 plus 3 plus 4 plus all the way up to plus 100. Okay. So we can do this now using our formula. So we're going from 1 to 100, so our formula says we should be able to get the summation by doing 100 times 100 plus 1 all over 2. In other words, 100 times 101 over 2, which is 5050. That is the sum of the first 100 integers using our n times n plus 1 over 2 formula. As we can see it set out there. So another example of using the formula is the sum of 3 times r from r equals 1 to 16. So if we just set this out as a pattern first and see what it looks like. So it's 3 times 1 when r is 1, then we get 3 times 2 when r is 2, 3 times 3 when r is 3, and we're going all the way up to 3 times 16 when r is 16, not to forget that sigma means find the sum of these terms. Now each of these terms contains 3. So we could take 3 out as a common factor. So we could write this as 3 times 1 add 2 add 3 add 4 all the way up to 16. In other words, we can write the summation as 3 times the sum of integers starting at 1 and finishing at 16. So that's 3 times. Now we can use our formula. The sum of the first 16 integers will be 16 times 16 add 1 over 2, which is 408. You can see the method set out there. In the next session we'll be looking at the standard formula for the sum to n terms of r squared and r cubed.